Alright, I had to stop the video because I had to check something and on this problem. So we're going to just start over really quick. So whenever you're solving an equation that deals with logs, you have two steps to follow. You have to convert it to the exponential form, and then the same thing that we did in the previous section, you change to a common base and solve. So for this one, we changed it to exponential form. We started with 3, we raised it to x, and then it equaled 81. So we got 3 to the x equals 81. We found a common base between 3 and 81, which is 3. And then you ignore the bases because they are equal. So the only way to continue making this equation equal is to take your exponents and set them equal to each other. And then you do that, you get x equals 4. Now for this one, we did the same thing. We took 4 raised to the negative 1/6 and it equaled x. We can't have a negative exponent, so we changed it to 1 over 4 to the 1/6 equals x. Now if you remember, anytime you have a rational exponent, technically you can take that rational exponent with its base and rewrite it using a radical. So x raised to a over b is the same thing as saying the b root of x raised to a. And that is the same thing as saying take the b root of x to a. So it doesn't matter which one you do first. Do you apply the exponent first and then take the root, or do you apply the root first and then take the exponent? So knowing that, here we have a rational exponent. So I just rewrote it as 1 over the 6th root of 4 raised to 1. Now we could go a little bit further and simplify this. You don't want to find a conjugate because it's a 6th root. It's not going to work the same way, and that was the mistake that I kind of made right here, and I had to cross it out. So that is going to be our final answer. All right, the next problem, pretty straightforward. Take 3, raise it to 2 equals my x minus 1. So 3 squared equals x minus 1. So what is 3 squared? It's 9 equals x minus 1. We add 1. So here x equals 10. Pretty easy. All right, I should have given myself a little bit more space for this problem, but before we actually go on with this problem, there is a mistake here. This should have been a 9. So you guys will have to change that on your own notes. All right. I'm just going to grab another sheet of paper because I will need some extra space for this problem. So let's do it on this, and we'll have a little bit more space where I'm not writing over everything. All right, so change to the exponential form. So this becomes 9 raised to the x equals the 4th root of 27 over 3. So I kind of see the similarities between 3, 27, and 9, but I have to get to that 27. So the same property that applied over here, how you can go from rational exponent to radical, we can also go from radical to rational exponent. So this I can rewrite as 9 to the x equals 27 to the 1/4 divided by 3. So now that I have this, I can see a common base between the 3. And what is that common base? It's going to be 3. So we end up with 3 squared, don't forget the x, equals 3 cubed, don't forget the 1/4, divided by 3 to the 1. So if I simplify this really quick, it's 3 to the 2x equals 3 to the 3/4 divided by 3 to the 1. So just like any exponential function, when you divide two things that have the same base, what do we do to their exponents? We subtract them. So now we end up with 3 to the 2x equals 3. What's 3/4 minus 1? It's negative 1/4. So now we have a common base. The problem is easy from here. So the next part is just taking 2x, setting it equal to negative 1/4, and divide both sides by 2. So x is negative 1/8. So it looks like a hard problem, but it's actually pretty straightforward if you know how to work your way around, because you want to get to that common base. That's really what you want to do in all of these problems. All right, I'm just going to move this out of my way. I'm going to put it up here for a minute. And we're going to move on. So now we're using the properties that we talked about in the previous video. We're going to use the properties to rewrite each logarithm if possible. Basically, for this part, we are expanding. And the only reason I know that is because everything is kind of compressed in all of these problems. So here I have division. So how do I separate that? Anytime you have a log with division, you can separate the two things being divided using subtraction. Pretty easy for this one. All right, here I have both multiplication and division. So start doing 1. I suggest you work with the division first and then break up the multiplication. So here we have ln of 4p minus ln of q. And now I can break up this multiplication into ln of 4 plus ln of p minus ln of q. As long as every log has only one term with it, I know I'm done. All right, moving on. So we have ln of x to the 5th, y to the 3rd, divided by 3. So here we have division, we have multiplication, and we have powers. So again, first break up the division. So let's break up the division, and we have ln of x to the 5th, y to the 3rd, minus ln of 3. Next up I'm going to do is I'm going to break up the multiplication. So this is ln of x to the 5th plus ln of y to the 3rd, and then of course don't forget the last part, ln of 3. The last I'm going to do is the power property. And if you remember, the power property of logs is you take the power and you bring it down to make it a coefficient. So this becomes 5 ln of x plus 3 ln of y minus ln of 3. So again, as long as every log has one term with it, that's as far as you can go. All right, this next one looks complicated, but it's not. All right, so when we're breaking this up, again, you see that you have a lot of things going on. In order for me to get to this division though, first, I need to break up this cube root. So the first thing I'm going to do is I'm going to break up that cube root by saying ln cube root of m to the 5th divided by cube root of kt squared. Now next up, I need to get to this stuff on the inside. So remember this property that we talked about over here? It applies. I want to turn that radical into an exponent. So this becomes ln m to the 5th raised to the 1/3, and then we have kt squared also raised to the 1/3. All right, so now I'm going to start dividing. I'm going to first get rid of the division. So this becomes ln m to the 5th raised to the 1/3 minus ln kt squared, still in parentheses, to the 1/3. All right, there's two things that you can do here. You can either apply, multiply in that 1/3 to all exponents on the inside right now, or wait and do it later. I'm going to do it now so that we can distribute it here, because a lot of students tend to forget to distribute it at the end. So the first thing I'm going to do is I'm going to rewrite this with distributing that 1/3 to everything. So everyone is getting, every exponent is giving that 1/3. Even this k that technically doesn't have an exponent, it has an exponent of 1. So this becomes ln of m to 5/3 minus ln of k to the 1/3 times t to the 2/3. And now I'm going to continue. Before I do the power property though, I want to break up these things that are being multiplied. So ln m to the 5/3 minus ln k to the 1/3 plus ln of t to the 2/3. Now you notice I put a parenthesis around this because when I broke this up, that negative does belong to this whole entire thing. So even though I'm breaking it up, that negative still belongs to this whole entire thing. And you'll see what I mean at the end, why it's important. Remember, negatives are those tricks that you have to remember to distribute. All right, now I'm going to apply the power property. So I'm going to bring down all of the powers that I see. So this becomes ln, forgot the 5/3, of m minus parenthesis 1/3 ln of k plus 2/3 ln of t. The whole idea is expanding, so we do have to distribute that negative to everything. So this becomes 5/3 ln of m minus 1/3 ln of k minus 2/3 ln of t. All right, so I know I'm done because the only thing left with the log is a single variable or number. Okay, so this problem was literally combining everything that we've learned so far on this page. Oops, can't see the bottom, my bad. I star it and I star it again and again because you are probably going to see this again. All right. Now this part is going the other way. So we want to use the properties of logs to rewrite each expression as a single logarithm. So basically what we're doing here is we are compressing them. All right, we're turning a long logarithm into a small one, into a single one. So you see how I worked before with division, then multiplication, and then the power property? So I'm going to kind of work a little bit backwards now. So the first thing I want to do is get rid of that 1/2 and that 2/3. So basically what that means is that that 1/2 is going to get put on the outside of whatever that is, because that's where it came from. So this ends up being ln p/3 q to the 4th in parentheses 1/2 minus ln p/4 q/3 in parentheses to the 1/2. All right, next up, there's a minus here. So I need to get rid of that minus. So that means these two things right here are going to be divided. So this is ln p/3 q to the 4th, all of that to the 1/2 divided by p fourth, q third, all of that to the 1/2. It looks like we're done because we're all combined, but you guys remember what we said about 1/2s, about rational exponents? They are actually radicals. So this is ln square root of p third q to the 4th divided by square root of p fourth q third. And technically these are both the same exact root, so I can put these guys together under one square root. So p third q fourth, p fourth q third. So how many of you think we're done? You would be wrong, because what can I do at this point right here? What happens to the p's and some of the q's? Yep, they cancel out. So I have 3 p's and 4 p's. Remember, when you subtract them, what do you end up with? How many? 1 p, and where is that p? On the top or the bottom? We know it's on the bottom. Here we have 4 q's, 3 q's, so when we subtract them, we have how many q's left? 1. And where is this one? It's on the top because it's positive. And now I have simplified my my equation. All right, and then the last thing here is this. So again, I'm going to start with the power property. So we have ln of 2y plus 5 minus ln of y plus 3 raised to the half. And now we have this subtraction, so this is ln of 2y plus 5 divided by y plus 3 to the 1/2. And remember, y plus 3 to the 1/2 is ln of 2y plus 5 divided by the square root of y plus 3. All right, don't think about conjugates, because remember, this is not a term by itself. It's still a log function, so we can't multiply technically by the conjugate. So that is as simple as it's going to get. We have one log function, and we can't really simplify anymore. All right, that is the rest of section 5.3. As long as you stay organized in your work, you should be good. Okay, the next section that we're going to do is 5.5. It's exponential and log equations and inequalities. We're actually not going to be focusing on the inequalities. In this section, the only thing that's different is you're still solving an exponential, but you'll notice you're solving an exponential when there is no way to find a common base. So we actually end up having to use a different base or logs to solve it, and that will be in the next video.